Good day everyone, and welcome to PAE 471 class. The course title is Chemistry and Toxicology of Pesticides. In this aspect of the lecture, we will discuss two important things. One is the mode of action of pesticides, and two, sources of environmental contamination by pesticides. Under the mode of action of pesticides, we're going to discuss them generally, and then we're going to discuss them specifically as it concerns classes of insecticides. When you talk about classes of insecticides, we refer to four major classes, and that is organophosphates, organochlorines, carbamates, and pyrethroids. We'll get there. First, let's talk about mode of action of pesticides generally. Most people know that insecticides kill insects, but how they do this, they do not know. Sometimes, when you have disturbances by these insects in your house, you go to stores and get insecticides and apply them in your house, and then they end up killing the insects. But how they accomplish this is what many people do not know. And so, how insecticide work to kill an insect is what is known as mode of action of that particular insecticide. A complete understanding of mode of action of insecticide is very, very necessary. It requires the knowledge of how it affects a specific target site within the insects. In the insects, the target sites for the insecticides is usually a critical protein or an enzyme right inside the insects. This is where the insecticide affects and alter it in order to bring about death on the insects. Although most insecticides have multiple biological effects on the insects, but toxicity is usually because of just a single major effect. Now let's go to the first group of insecticides and how they act to kill insects. This first group is what is known as stomach poison. Stomach poison are insecticides that kill insects when the insecticides find their way into the stomach of that particular insect. Without entering into the stomach of that particular insect, they cannot bring about death. And they must do this by passing through the mouth of that particular insect and then get to the stomach before they will be able to act. Stomach poisons are useful to kill a particular types of insects. These particular types of insects are insects that have biting or chewing mouth parts. Again, biting or chewing mouth parts. And such insects are caterpillars, beetles, and grasshoppers. Why are stomach poisons effective against biting and chewing mouth parts insects? This is because stomach poisons are applied as sprays or dusts on the leaf or stem of plants by the target insects. When you apply the insecticides on the leaves of the stem of the plants where the target insects stays, the insects feed on the leaves and then or crawl on the stem and pick up the insecticide by their mouth. And then the insecticide goes deep down through their mouth into their stomach in order for them to bring about death. And that's why they are called stomach poisons. Stomach poisons have gradually been replaced anyway by synthetic insecticides, which are less dangerous to humans and other mammals. That's about stomach poisons. We now want to talk about contact poisons. Contact poisons act in different way. Unlike stomach poisons, contact poisons do not need to get to the stomach of the insects through its mouth. Rather, contact poisons only need to make contact to the body of the insects, to the skin. When contact poisons make contact to the skin of the insects, they penetrate the skin of the insects and get into their body. These contact poisons are used against those arthropods, such as aphids, that pierce the surface of a plant and suck out the juices. They are used against these insects. Just take note that the contact insecticides are divided into two main groups, which are the naturally occurring ones and the synthetic organic ones. The natural insecticides are usually short-lived on plants. They do not last longer and cannot provide protection against prolonged invasion. Just take note of this. Except for pyrethrum, they have largely been replaced by newer synthetic organic insecticides that may last longer than the natural ones. We now want to talk about the growth regulators. The growth regulators, they are chemicals like other groups also. They are called growth regulators or IGR in the sense that they prevent the insects or the pests from reaching its full growth. They, when applied to larva or pupa stage of an insect, they can prevent the insect from growing up into adulthood. And you know that most insects cause damage when they are get to adult stage. Their larvae and their pupae may not be able to cause any harm. And so, when the growth regulator insecticide prevent them from growing into adulthood, you have successfully controlled such insects because they will not be able to cause harm at the juvenile stage or at the immature stage. Let's talk about the surfactants. Surfactants are very refined oils and they can be used as larvicides or pupicides. That means you can use them to control larvae and pupas of insects. They have the ability to kill both stages of the insects. Now, when you apply surfactants on larvae or pupae, what does it do? The emerging mosquitoes are unable to fully emerge and they will drown in their breeding sites. For example, mosquito larvicides and pupicides are effective on all species of mosquitoes that breed in standing water and required air stroke water interface in their life cycle. So the surfactants most times prevent the larvae and the pupa in the breeding site from getting enough oxygen from the in the breeding sites, and as a result of that, they might suffocate. These stages of the mosquito will suffocate and die. We will now talk about fumigants. Fumigants are toxic compounds that enter the respiratory system of the insects through its spiracles. The spiracles of insects are otherwise known as the breathing openings on the body of the insects. The fumigants are used mainly for killing insects, pests of salt products, or for fumigants nursery stock. They are usually best in killing insects in stored products in the warehouses. Well, that's all on that section. We now talk specifically on mode of action of some classes of insecticides. These classes of insecticides, the first we'll talk about is the organophosphates. The organophosphate insecticides affect the nervous system. They affect the nervous system of the insects. The organophosphates, they are synaptic poisons. They are synaptic poisons. And what is a synapse? A synapse is a junction between two nerves or nerve connection points in the insects. Hence, the name synaptic poisons for organophosphates. Specifically, organophosphorus insecticide bind to an enzyme found in the synapse, and this enzyme is called acetylcholinesterase. The enzyme is designed to stop a nerve impulse after it has crossed the synapse. But when organophosphates or organophosphorus insecticides bind to the synapse, it prevents the enzyme from working. Therefore, poison synapses can no longer stop the nerve impulse. And when they can no longer stop the nerve impulse, what happens? The continued stimulation of nerves occur as observed with pyrethroids. Poisoned insects then exhibit tremors and uncoordinated movements, which may subsequently lead to death. This is seen in application of pesticides in your houses. Sometimes when you spray pesticides to kill some insects, you see the insects run and then fall, exhibiting uncoordinated movements, and at a point may not be able to stand and continue running. And then it will stop there, and then death may occur in such insects. That is what the organophosphates do. Then let's talk about pyrethroids. Pyrethroids are synaptic chemicals whose structures mimic the natural insecticide pyrethrum. These insects are found in flower heads belonging to the family Compositae. Also, pyrethroids are ozonic poisons. As ozonic poisons, they poison the nerve fiber and they bind to a protein in the nerves called the voltage sodium channel. Again, the pyrethroids bind to the voltage gatum sodium channel, and when they bind there, they prevent it from closing normally. The voltage gated sodium channel will no longer close appropriately, and this results in continuous nerve stimulation. This explains what I've mentioned earlier, the tremors exhibited by poisoned insects, and those insects lose control of their nerve system and are unable to produce coordinated movement, and subsequently death may occur. Then on organochlorines, this class of insecticides have varied targets and mechanism of action within the CNS. The CNS is the central nervous system. So the organochlorines have varied targets and mechanism of action within the central nervous system. The organochlorines affect the function of the sodium and calcium channels and transporters. They block specific receptors in the insects, contributing to their neurotoxic effect to the insects. We'll now talk about carbamates. Carbamates are a class of insecticides structurally and mechanically similar to organophosphates earlier discussed. And while the carbamates possess a similar mechanism of action to the irreversible phosphorylation of acetylcholinesterase by organophosphates, carbamates bind to acetylcholinesterase reversibly. They bind to acetylcholinesterase reversibly. Carbamates have a similar toxicological presentation to organophosphates poisoning with a duration of toxicity that is most times less than 24 hours. That's about the carbamates. And if you look at the figure below, figure 2, you will see the different sites of action of these 4 classes of insecticide that we have discussed: the organochlorine and the pyrethroids acting on enzymes and axonal membranes, while the organophosphorus and the carbamate esters acting on enzymes and neurotransmitters. Well, that's all the reminders that we can take from the mode of action of insecticides. We now want to discuss the movement of pesticides in the environment. Under this section, we will first discuss sources of environmental contamination. Pesticides may move from one place to another. Pesticides may move from the site of application. The site of application is the place where you apply them to kill certain pests. These pesticides can move from that same spot to another place in different ways. How? They can move through air, they can move through water, they can move through soil particles, and even in objects. When we talk about objects, we'll talk about the application equipment used to apply such insecticide can take insecticide residua from one place to another through movement. Objects can also be animals or even humans can aid to move pesticides from one place to another and use them to contaminate the environment. The major sources of environmental contamination by pesticides is deposits resulting from application of this chemical, like I've mentioned. When you are using them to control agricultural pests or stored product pests, or even pests of medical importance. There's no way you can apply the pesticides without having some residues of it in either in clothing of the person that applied them, or even the ones that dropped on soil can be moved by surface water or even by air that blow soil away. Other sources of contamination could be pesticides used in urban areas and industrial wastes. They can still move from one place to another through air, water, and objects and get to other places where the pesticides were not originally applied, and as a result, contaminate the new environment. Misplacements and leakages during transportation, distribution, or storage processes related to the manufacture of pesticide could result in environmental contamination. There have been cases where trucks transporting chemicals from factories to farmlands or farmhouses had accidents on the road and spilled such pesticides. And then the pesticide moves into the air, into the water, and several other places that are not the original targets. So in this way, pesticide can move to contaminate the environment. In any case, the pesticide enter the environment. They are absorbed by various constituents of the environment, and transported to other places, like we have mentioned, by water and air movement. When they are transported, they are picked up by various biological systems and at the same time chemically or biochemically transformed to other non-toxic or toxic compounds in the environment, as the case may be. And when they are transformed to toxic compounds, it becomes a problem to man and its environment. Now let's talk about movement of pesticides on objects, that is, plants and animals. Objects, plants, and animals. Pesticides can move from the application site when they are in objects or organisms that move from where the pesticides are applied to other places. For example, humans who apply the pesticide at the end of the day will move from the site back into their homes. And when pesticide handlers, which are humans most times, brings or wear into their houses protective equipment that they use to apply pesticide, they wear them back home, or those working clothing, or even other items like sprayers and pumps, pesticide residues may rub off on the carpeting in the house, in the furniture, and laundry items, and onto pets and people. And when this happens, the human or the handler has successfully contaminated that new environment. From the pesticide they pick from the site of application into the new environment. We now talk about movement of pesticides in the air. It can happen by drift. And what is drift? Drift is the movement of a pesticide from the application site by wind or air currents. People who mix or load or apply pesticides in farms or any other places are usually aware of how these pesticides may drift off-site. And when they drift, they may travel as spray droplets, as vapors, as dusts or solid particles, and even on blowing soil particles. That's about how they move on air. Let's talk about how they move in water. Most off-site pesticide movement in water is either by water runoff, that is surface water movement from one place to another. It can be erosion that occurs when there is a rainfall. It can be water sources that come from a water discharge in industries, in urban centers. And when they move through drainages, they can wash away pesticides and move them from one place to another. Also, pesticide movements in water can also be by leaching. Leaching is the downward movement of water through the soil. Runoff and leaching of pesticides may occur when, number one, when too much pesticide is applied or spilled onto a surface, or when too much rain or irrigation water move pesticide through the soil off-site into a groundwater. Highly water-soluble or persistent pesticides are used. Run-off water may move pesticide into drainage system, streams, ponds, or other surface water where they can travel great distances. Pesticides that leach downwards through the soil may even reach the groundwater deep down. We now want to talk about pesticide contamination of surface water. Pesticide contamination of surface water. Surface water is often a source of drinking water, like in most communities, Surface water may include water in domestic water containers, in the houses. It may include stream, rivers, ponds, and lake. All those waters that are exposed to the atmosphere are all known as surface water. And pesticides can contaminate them. And these water bodies serve as source of drinking water to several households, more especially in the rural areas. And when people drink from such, it's a very serious health concern. Pesticides that move in runoff water or with eroded sediment may contaminate plants and animals located downslope where they are flowing to, and reach sources of water such as stream and lake, like we have mentioned. And so this is a very serious problem, very serious problem. In urban areas, runoff may occur on hard surface when pesticide granules are left on sidewalks and streets, which is a common practice in some places. Runoff is a potential problem, and most pesticide application sites, runoff do occur and then move the pesticide into water bodies. Generally, runoff risk is greatest when heavy rains follow shortly after application of pesticides. Immediately after application of pesticides, when the pesticide have not degraded and there is an immediate rainfall, it can actually move the pesticide into water bodies. Now let's talk about pesticide contamination of groundwater. Naturally, groundwater is big. Groundwater provides about 70% of water used for public and private water supplies. And groundwater even supplies water for irrigation and industry. Many people in urban centers tap into the groundwaters as boreholes, drillings, and in different other forms. And so it supplies a whole lot of people with water for daily activities. Just like surface water, there is need to protect the groundwater from pesticide contamination, because one major reason why we need to protect the groundwater is because once the groundwater is contaminated by pesticide, correcting the problem is difficult or even impossible. If surface water, like water in domestic container at home, is contaminated by pesticide, you can easily pour it away and wash the dish and replace the water. But once it contaminates groundwater, it is very, very difficult, or even practically impossible to correct it. This is the reason why we must protect the underground water or the groundwater. The groundwater is found underground in cracks or in the bedrock and in the spaces between soil particles, gravels, and rock. It is the source of water for wells, springs, the layer of soil, sand, gravel, or fractured bedrock in which all available spaces are filled with water is known as the saturated zone. So the boundary between the saturated zone and the overlaying unsaturated rock and soil is known as the water table. And the overall geologic formation from which groundwater can be drawn is called the aquifer. So the figure 3 demonstrates the movement of pesticides in the environment. You can see photodegradation from the sun. You can see the breakdown and then the runoff that goes into water bodies below or down the slope. You can see spray drifts, and you can see how absorption takes place and then how chemicals are broken down. You can see also how microbes act to break them down, and then lynching also occur. So this is how far or how much we can take as a reminder in this lecture. So generally, remember that mode of action of as pesticide or insecticide are grouped according to classes, as in pyrethroids, organochlorine, organophosphates, and carbamates. And also generally, they are grouped as contact poisons, stomach poisons, fumigants, surfactants, among others. And then sources of contamination of pesticides in the environment can be through air, it can be through water, and it can also be through objects, which may include animals and humans. That's all we are going to take in this class, and I hope that you enjoyed the class. Thank you.